Welcome to the iCode plus Texas Instruments Bootcamp Spring Break Pilot Program training video. I am Carter Ash. I am a curriculum developer at iCode Corporate. I am mainly responsible for working on this bootcamp. So throughout this video and throughout your location's execution of the program, if you have any questions regarding uh, the curriculum, outcomes, execution, hardware maintenance, um, anything like that, please contact me. My email is carter.ash@icodeschool.com. In this video, we're going to look over the learning objectives and the hardware requirements for the course and some tips and tricks on how to get the best execution possible for this program. More specifically, in this video, we're going to look over two main areas. The course overview, which we will look at learning objectives, day structure, instructor pilot notes, material layout, and hardware grouping. So all the educational aspects of the curriculum. And then we will take a look at some video demos of the hardware training. And that's going to include getting started with TI, which is all of the TI resources provided through the TI website and user guides, which they have many PDFs in terms of user guides and manuals on how to work with the hardware, as well as additional training and exercises you can do to prepare yourself for this course. We'll also take a look at the TI Nspire CX2 handheld, which is the scientific graphing calculator used throughout this course. And you will see very quickly that this graphing calculator is not like the graphing calculators most of us probably saw in school. These graphing calculators are very sophisticated and can handle a wide variety of tasks. We'll also be taking a look at the TI Innovator Suite, which is the TI Innovator Hub, which is a small microcontroller used to control physical programming, as well as the TI Innovator Rover, which is a small pre-built rover unit, which allows us to create physical tracks and mazes and drawings. It's a very, very unique piece of hardware. So we'll dive into all that in the coming sections. The first thing you may be wondering is, what are the learning objectives? What will the students get upon completion of this course? There are three main areas of learning objectives for this bootcamp. That is TI hardware training, STEAM objectives, and Python 3 programming. For the TI hardware training, the first area is state-of-the-art graphing/scientific calculator training. With the Nspire CX2, students will learn the general operations, how to navigate the buttons, how to do operations multiple ways. On these calculators, you'll see that there are a multitude of ways to complete a single task. Students will also learn about creating and working with documents. As you'll see later on, there are a whole host of file types that can be implemented into a single document that, with the proper training, can incorporate data transfers from one file to another. And you can use Python programs to grab from spreadsheets, and you can use note documents to write out ideas and brainstorm all within the calculator. Students will also learn data analyzation using spreadsheets, graphs, and text documents. Students will also get TI Innovator product training. That is the hub and the rover unit, as I mentioned, we will see later on. The hub unit is a microcontroller. So if you've ever used a Raspberry Pi or an Arduino, this is Texas Instruments' version of a microcontroller. The microcontroller is a standalone unit that can be programmed through the calculator, or it can be a bridge between the calculator and the rover unit to drive. Students will also get practice in what I call physical programming, and that is programming using sensor data and robotics objects, which is the rover and all the different armatures attached to the rover. For STEAM objectives, students will learn a wide range of topics that extend projects past programming and TI. Things like color theory, pixels, artistic design. Some courses have animation, talking about frame rates, data collection and graphing again, and additional geometry and digital simulation of space. So students are going to, through every course, touch on some STEAM objective and then use those STEAM objectives to further their problem solving, their programming, and their use of the TI hardware. These STEAM objectives are very important because they give the students the ability to think past the TI hardware and the programming and think about the real world and how we can use engineering tools like the TI hardware in order to create unique solutions to unique problems. The third objective is the Python 3 programming. This course is completely full of Python 3 programming, from the basics of input-output using the print, format, and input methods. Students will learn about structure like if-else statements, automation with looping, and modularization with functions. Students will be taught about user design thinking, creating efficient programs, and focus on creating algorithms that are less time consuming than others. The iCode and TI Bootcamp pilot course is a 3-day long course. It is structured in the length of a camp, whether spring break, holiday camp. It is a full day course from 9 to 4. And the next 3 slides will outline what those 3 days will look like. You might notice right off the bat that there are only 3 boot camp classes offered per day. And that is because the material for the boot camp is it's very rigorous, and the amount of programming done in the course is intense. And so we decided that asking the students to program from 9 in the morning till 4 in the afternoon, while it might be very educational and productive, the students in a camp setting may not respond in the best way. So we will only be offering 3 of the bootcamp classes per day. In between the bootcamp classes, you will be hosting a supplemental activity, an iCode activity. This could be drones, robotics, Raspberry Pi, or even Minecraft. I will have a list of suggested supplemental activities, but it will be up to your location and the different camps that you are offering in the same time frame in order to choose which activities are right for your location. If your location is running a drones camp, chances are you're not going to be able to use the drones as a supplemental activity in between the different boot camp classes. So again, I will have a list of supplemental activities, but it will be up to your location to decide what those supplemental activities will be. So looking at the structure of the day, before the day starts at 9, you'll have the classroom setup. This is where the instructor will ensure that the classroom is clean and ready to host the students. The instructor will distribute files needed, starter files needed to the handheld units, and just general class organization. The start of the day is at 9 a.m. and for about 15 minutes, the instructor should host a introduction period to the class, welcome the students, have general discussion, allow students to meet each other and connect and talk amongst each other. You can have a warm-up activity or puzzle. There are many different things that we recommend at iCode to our instructors. Free online programs like Drawlosaurus or Kahoot. The Towers of Hanoi project is a great puzzle for them to take about 15 minutes to execute and just get warmed up for the day. Maybe get all the sillies out, maybe play Simon Says, whatever it is, just get ready for the class, give them a moment to compose themselves. The start of the day is going to start with a boot camp class. And for day 1, that is the TI User Guide program. In class 1 of the boot camp, students are going to be introduced to the TI handheld. That's the CX2 handheld graphing calculator. They're also going to be introduced to the basics of Python 3. So this course has a lot of introduction material to both the hardware and the programming language used throughout the course. So the activity for the course is a program where students are going to explore the handheld and they'll explore the user manuals associated with the handheld to learn a few new tasks or operations with the handheld. They will then implement those into a Python program which allows the user of the program to input a command and they will receive an output of directions on how to execute a certain operation. The second boot camp class offered for day one will be class 2 of the boot camp. This is a homework processor program. I have homework spelt wrong, but that is okay. The homework processor in the class material, the students are going to learn a majority of the basic arithmetic operations of Python. So they're going to learn plus, minus, divide, mod, all these different components of Python, as well as variables. And the activity is the students will be building a homework processor. So at the start of the program, the students can input the number of questions that they received for their homework and what type of math operation, and then they'll simply input the numbers for each equation, and the program will process the output for them. For the third class, students are going to be practicing conversions with constants. So the two main activities are building a time conversion program where the user can input seconds, minutes, and hours, and it will output a downgraded version. So if they input hours to minutes, the number of hours that they input will return that number in minutes. Same thing with minutes, it will tell how many seconds that conversion. And they will also be building a weight converter. So we pose the question of what is the weight of something on Earth and what would the equivalent weight be on Mars. So they learn about gravity constants, and they strip weight of its gravity constant depending on the planet, and then they implement the other planet's gravity constant. On day two, students day two has the same structure, so I won't cover that. Same thing, start of the class, you've got introduction, then you're going to do a boot camp, iCode activity. So days 1, 2, and 3 all have the same structure in terms of when activities are executed. The first boot camp class executed on day 2 would be class 4 of the boot camp. This is a very fun class where the students learn about the process of animation using Python. So students will dive into the geometry section, the geometry module provided by the TI hardware, where they can build polygons and lines and shapes, triangles, circles, all these different things. They can fill them with colors. They really have a wide range of abilities with the drawing aspect. So we incorporate teaching these STEAM concepts, coordinates, XY coordinates, shapes, angles, arc lengths, things like that, and then we ask them to turn around and create an animation. So the final project for this class is the students will create a few different animations. The final one is of a face that when the program runs, the user can input a sentence or a string value, and the animation will move the face's mouth and output the text onto the screen so it looks like the animation is speaking to them. The second bootcamp class offered in day 2 is class 5, and this is sheet music with the hub. So the students are now going to be introduced to the TI Innovator Hub unit in this class, and with this, there is a built-in speaker to the hub. The students will be introduced to sheet music and learn how to read the notes and the note lengths of the sheet music, and then use the TI Hub sound module to reproduce the songs that they find on. We have a few songs provided. We have they're Star Wars themed. It's the Cantina song and the Imperial March song. So the students will practice with both of those songs, and they have to read the sheet music, write the corresponding notes into the actual method calls in Python 3, and then when they run the program, the song will play back. This is a really fun activity. The students will get to learn not only about programming, but they also get to learn about music in the process. And there are additional challenges associated with this course or with this class where the students are then asked to group up with other students and create harmonies. So essentially, multiple students reading sheet music, changing octaves, and playing a more robust sound is a very fun activity. Class 6 is a little intense. The students are going to be introduced to two sorting algorithms. That is going to be the bubble sort and the selection sort. The students are posed with a problem set that says a city in Texas is looking over the electricity bills of 1,000 residents. Those bills are not in order. So the students need to use a sorting algorithm to sort all the bills so that they can find the lowest value and the highest value as well as the average. This is a dual objective project where the students are focused on processing data, finding the minimum, maximum, and the average of some set of values, as well as starting to understand algorithms and time complexity. So along with processing the data and outputting it onto a graph using Python, students will also be setting up timers within their sorting algorithms in order to see which algorithm sorts the fastest. Um, it is a very basic introduction to time complexity, as the students will create a timer at the start and the finish of their sorting algorithms. But if they complete that in time, we also ask them to implement timers within the various nested loops of the sorting algorithm, which then will show the representation of time complexity over a set of data. Because if you know about the bubble sorting algorithm, it has a time complexity that is not that bad until you get to a large data set. So as the data grows and the amount of data that the program has to process, the time slows down, as opposed to the selection sort, which is a static time across an entire data set. So the students get to explore a lot of different things with this class. It is a little more intense, but the project files that the students receive have all the information they're going to need. Both the bubble sort and the selection sort are completely outlined for them. They simply need to read the starter file and implement the code into their own project. For day 3, we focus on a lot of Hub and TI Rover programming. Oh, to mention as well, in day 5, the students will also be introduced to the rover. There are a couple different projects within classes 5 and 6 that introduce the rover and how to drive with the rover. So don't think that they're not getting rover time as well. Actually, in class 3, the students will learn about functions, and we use the rover to demonstrate the use of functions. So I know that it's not mentioned here, but they will be using the rover. Just dive into the curriculum and you will see that there are plenty of additional activities that I'm not outlining in this video. But for day 3, in class 7, the students are going to be working on a color sensor calibration. The TI hub, the Innovator Hub, has a LED which can be programmed to display different colors, all RGB colors. So you can get, solid, anything from solid red to solid green to solid blue, black, white, all the different colors are available. And what we do is we build a program and we say that we want to calibrate the color sensor on the TI Innovator rover. So the rover will be mounted above the hub unit, and the hub unit will display a light. And the color sensor on the rover will make an output if it senses red. So it's obviously the color sensor and the LED light on both the hub and the rover work perfectly fine, but it's just a fun activity for the students to practice using the sensors on the rover. So this is actually the first time that the students are going to be using the sensors on the rover. Class 8 is another program which might take a little while, but up to this point, with all the training that the students will have, they should be able to complete it with ease. It is a picture filter program. So the students are going to be able to upload a photo to the handheld. They're actually going to be implementing a photo, uploading it to the handheld, and then using a Python program and the TI image library to parse through every pixel on an image. They're going to create a filter. So the filter will say any pixel that is red, turn it to blue. So I don't have the demonstration on this video, but I have a picture of my dog and she's wearing a red sweater. And the program will sort through every pixel on that image, identify any pixel that is red, which would be the red sweater, and it changes it to blue or green or whatever color the user would like to change it to. This is a really fun activity as well. Really cool to see that you can modify images in such a robust way with the TI hardware. And class 9 is going to be drawing with the rover. You will be getting an email from me, probably along with this video, on a sheet of paper that you should purchase, a large sheet of paper to allow the rover to draw. You'll see in the hardware demo that the rover has a holster for a Sharpie pen, so that when it drives, it can actually draw as it drives. This is a very fun little addition to the rover that you don't see on a lot of robotics hardware of this caliber. The program itself has to do with the TI image library seen in class 8, and the students will take a two-colored image, a solid black and solid white image, and the program will process the outline of that black image against the white background and then have the TI rover draw that image on a piece of paper. So they're going to be doing some of the same mechanics as they did in class 8. They'll be parsing through an image, but now they're going to take that and they're going to add it to the physical programming, where they're saying there is a border at X5, Y10. And then at X5, Y11, there's also a black pixel. So they create this polygon shape that they will then be able to have the rover draw on a piece of paper. That is all the curriculum outline for the course. Again, if you have any questions on the additional projects or learning objectives within the class, the instructor notes have all of this outlined. You'll be able to see what are the learning objectives, where are the additional activities, all those things. Each class has multiple activities, so as they're learning about the Python or they're learning about the TI operations, they're actually doing those things. So please make sure that the students have calculators in their hand, they have their software up, so that when you are teaching how to do a for loop, the students aren't just sitting there watching you talk about how to do a for loop. They're actually attempting to write the code for themselves. There are additional activities that specifically instruct them to write the for loop, but while you're teaching it, the best method for having these students learn Python in such a short period of time is to really get them to be writing code as you are executing the classes. This course offering is more than just a camp. It is a pilot program. Locations, instructors, and campers will all be experiencing these courses for the first time together. The goal of this program is first and foremost to give our campers an amazing iCode time, but it is also to assess the mechanics of the iCode plus Texas Instruments Bootcamp. Please take notes on how your bootcamp classes run. Here are some main points to look out for and report back on. Are the campers having fun? Did they seem interested in the material that they were learning? Were they engaged? Were the class communication and discussions effective? All those kinds of things. Can campers complete the material in 1 to 1.5 hour blocks? The boot camp will be offered by each location in 1 hour blocks. Some locations offer them in 3 hour blocks. So I would really like to know if one course, one boot camp class takes an hour or more to run. I know that there's a lot of material in each class. There's a lot of Texas Instruments hardware training. There's a lot of Python programming. So I'm very interested in ensuring that these courses are built in the correct time frame. Does the material per class flow in a logical way from start to finish? Do the students know where they're going? Are they engaged? Are the learning objectives outlined in a way where they build upon each other? And were the resources provided adequate to executing the course? Were you able to access the material? Were the starter files correct? The completed files are for the instructors, so were those completed files to your needs? Did they help you help the students complete the projects along with the additional instructions? And just general feedback, any sort of information that you think is important for me to know when going back and revising the courses that you executed. Anything that comes to mind, I want to know all of it. I want to know everything. Don't hold back if you really would like to see some class changed or your class did not respond to some activities in a desirable way. Please write that down and let me know, because this is a pilot program. We are working through this brand new curriculum and the brand new hardware. So it is very important that you, as the instructor or the director, gather feedback from the execution of the class and the general feedback from the students. So let's take a quick look at the layout of the material. You, as an instructor and a location, will be able to find the course material on Basecamp. By the time you receive this training video, there will be a section in Basecamp, whether it's in the holiday camps or in a special TI bucket for you to access the different days of material. For each class, there's a folder, and it will have the following material: the class presentation, which is a PowerPoint, which you can open up in Google Slides and present; instructor guide, which is also a PowerPoint and can be opened in Google Slides. This is just for instructors to view. So if you have an iPad or an additional laptop, this would be a great place to execute that slideshow. There will also be a number of starter files and completed files, which are usually of the TNS type. That is the Texas Instruments file that contains all the different documents that would be within a project. So you'll definitely see that as you go through the material, what a TNS file is. The number of starter and completed files will vary per class depending on the number of activities the students are asked to complete. A lot of times there's a starter file. Sometimes there's not a starter file. Sometimes we ask the students to create a file from scratch and work through it. Sometimes, like the weight conversion program, there's a starter file for students to work through. Additionally, I think in class 3 or 5, there's the TI, the music, where they're learning about the sheet music. Both instances of the sheet music will be found in that folder. So you should be able to find all resources and material within the folder. This course has multiple hardware units. So let's take a moment to look at the hardware grouping. First, you have the handheld, the TI Nspire CX2 handheld. That is going to be one per student. That is very important that each student has their own handheld to work with throughout the course, being that the handheld is where they will run all of their code. They should have the ability to write their code on their computer, upload the code to their handheld, and test it at their own will. Not having to wait in line and to share this piece of hardware is very important as for the flow of the course. Additionally, there is the TI Nspire student software, and that should be one license per student. So each student should have their own computer to work on and their own handheld to work on. We'll see in a moment that the student software is an emulation software of the handheld. It's a great place to write the code on a computer and then upload it to the handheld. Furthermore, we have the TI Innovator Hub and the TI Innovator Rover. Both of these are one unit per three to five students. So we'll see that the hub works with the rover, and that unit should be for every 3 students to 5 students, there's one hub and rover. Now, I know that the hardware that your locations received was additional hub units, so that is great. You won't have to share the hubs as much when it comes to the music programs and things like that. But when it comes to the grouping of the hub and the rover together, working together, it is important that is 3 to 5 students. That is because the students will write their own code. They could be working in groups, but they'll write their own code and they will run the code, and then they can hand the rover set off to the next student to test their code. So there's a little bit of an iterative process, a little bit of round robining going on here. So 3 to 5 students per hub setup. Before we get into the video demos on how to work with the hardware, let's talk about how you as an instructor can gather extra resources for working with the Texas Instruments suites of hardware and software. The Texas Instruments website has an unlimited amount of training material. Seriously, this link right here is the top link for you to go to and explore the different aspects of the TI products used in this course. Resources like pre-built classes and training exercises and videos and articles on how the hardware works can all be found at this link. You can find specific information regarding the TI Nspire CX2 handheld at this page. This is a link, a sublink of the previous link you just saw. This page will cover everything having to do with the handheld. Same information as I mentioned above, training resources, pre-built classes, videos, articles, everything you could possibly want to know about the CX2 graphing calculators can be found at this link. You can find specific information regarding the TI Innovator Hub/Rover at this page. Again, this page is full of additional resources and even activities. So if you want to practice some things on your own or introduce the students to some of the resources that TI has built, feel free to explore these links. For getting resources and user guides, please use the link below. These resources are very powerful and will ensure that you, the instructor, know all the ins and outs of the TI hardware. This whole course is centered around TI hardware training, so it is crucial that you are competent with these tools. If you follow this link, you will find a database which you can then search specific tools, whether it's the Rover, the Hub, the handheld, the student software, programming guides. All of those things can be found at this link. And to help you out, I've actually outlined some of the key user guides that you should take the time to look into and read, as well as some of these guides will be used throughout the course. Additionally, with the course material that you will receive on Basecamp, there will be a folder with these PDFs already downloaded and accessible through those folders. So I highly recommend you take a look at these resources. Furthermore, the Python 3 programming is essential to this course, and TI has a whole suite of Python 3 modules that are built into the handhelds, which are used to control graphing, image processing, time, all these different statistics, all these different abilities of the calculators, as well as controlling the hub, controlling the rover. So this link right here will be presented many times throughout the course, and the students will be asked to explore the documentation. Through some of the courses, we explain what documentation is, how to read it, how to get the necessary information from the documentation. So please take a look at these because these are the modules being taught throughout the course, along with foundational Python 3 concepts. These modules will be used to exemplify the TI hardware. The first piece of hardware that we're going to take a look at is the TI Nspire CX2 handheld. This is a screen grab from their website with the different file types that we will be working with throughout the course. And on the right, you can see an image of the handheld itself. You've got a whole array of buttons and a D-pad and a color screen for viewing the different documents that students will be creating. In the hardware demo, we're going to be taking a look at these concepts: power on and off, navigating with the D-pad versus mouse versus using buttons. We'll take a look at the home screen, how to create new documents, the graphing/calculator functions. We'll look at the menu, we'll look at the second button, which is very important, and we'll also take a look at the editor menus. We will also dive into Python 3 programming with the TI calculator. Additionally, we will look at new document creation, the templates you can use. We'll create a basic hello world program to demonstrate running and executing programs. We'll take a look at the Python editor menu within the hardware. We'll also take a look at the modules within the Python editor menu. We'll take a look at what it looks like when you get an error and how to overcome errors within your program. And we'll also take a look at shell outputs. This is the TI Inspire CX2 handheld. It comes with the handheld and a protective case, which can slide off like this. And it actually, if you flip it, you can put it back on the back of it so that you don't lose it. It's a nice little feature. So the first thing we're going to look at in this demo is how to power on and off the calculator. Very easy to do. The top right button is the on/home button. And so all you need to do is press it, and it takes just a moment to turn on. If this is the first time opening it up or turning on the handheld, it should be charged already, but when you turn it on, it will have a simple setup menu asking things like language, font size, things of that nature. But after that, after you've done the initial setup, when you turn it on, you should be presented with this home screen unless you had already been working on another file or project. It will also open up to that project that you were working on previously. So that's how you turn it on. To turn it off, you press the second button, which is this blue one on kind of the middle left. You press blue, which is control, and you will press the on button again to press off. It's going to save whatever project you're working on temporarily and shut the handheld off. So turning it back on, there's a few ways to navigate it. You can navigate it with the D-pad, the mouse feature that's on the D-pad, or you can use the button controls to navigate. So first we'll take a look at the D-pad. So simply by pressing up and down and right and left on the handheld, you can navigate through different options. I can click the center to select. So that's how you use the hand or the D-pad. So if I go to 9, this add program editor, you can see there's a little arrow right here. If I press side, it's going to open the next menu to work with. If I press this escape, it's going to get me out of here. I'll press the home button, the on button. When the handheld is on, if you press the on button again, it will take you to the home page. So you can see the little home icon next to the word on. So I just press that, it takes me back. So the other way to navigate is going to be with the mouse feature. So with the D-pad, if you touch the center and then move your hand around or move your thumb around, you should be able to use like a mouse. So kind of like a trackpad on a laptop, but you use one finger. This is good for when you're working with graphs and you're trying to grab things and manipulate them. So if well, I won't mess with it too much, but you use this, you can select and grab the little mouse icon will change to a grabber hand, and you just select and then you can move around. So you can actually see right here that the little blue is the select. So you can actually choose second and select, but when the attribute that you're trying to work with is grabbable, this will automatically happen. So that's the mouse, and same thing, I can click here and then I can use the mouse in the same feature. You can see that the actual mouse icon is gone, but I'm using it in the same way. I'm not pressing the buttons, I'm simply scrolling with my thumb. I don't usually use the mouse feature in settings like this because I find that using the buttons is faster, but like I said, when you're working with different attributes, or if you're in the notes and you do some different lines, you can use the mouse as a cursor. You can actually grab and highlight entire sections, and then you'd be able to do different things. Text color, we can change this text color to yellow if you want. It's kind of obnoxious, but so we can go back home. And the final way to navigate through the handheld system is with the buttons itself. So you can see that all these options are outlined in numbers. So A would be to get a calculator. So if I press the A button, which is right here, if I press A, it will take me to a calculator. If I press B, it will take me to a graphing feature. And then 1 2, 3, 4, and 5 take you to these settings, which are different document settings. So like if I press 2, it will take me to the browser, which I don't have outlined in the things we need to cover, but if you want to, you will be able to save your files onto the handheld directly. So if you press 2, it's a great way to get to your different files and things. You can see I have most of the files for the bootcamp already on here, as well as some other additional folders with different class projects and things. So we already covered the home, so we'll skip over that. And we've touched on new document. So new document is usually how you're going to start your projects. You'll press 1, and then you'll get this list of options, different file types that can be added to your pages. I'm going to add a note. And now I have a project. I can save this by pressing this second button, which we'll cover in a second. Second save, and I can save this. We'll save it as test. We'll say test 1. So this is test 1 project. Typing with these is a little uncomfortable just because it's A through Z. It's not as a normal keyboard would be. So it's all A, B, C, D, E, F, G, H, I, J, K, all the way through to Z. And it's not your standard computer keyboard. But if I save my project, let's see, save. So that's creating a project. I can add other documents or other files to this single project by doing second page. And this is going to insert a new page. So let's say that I want to add a Python program now, and I want to add a new I'm just going to do test again. We're going to do test pi. If I can find the P. There we go, test pi. It's going to be a blank program. And so now I have 2 documents on this, or I have 2 files on this document. And the way that you switch between the 2 is you would do the second button, and you can see that this has these little page arrows. So that's how you jump between tabs. You do second tab. So when I do it and I don't press second, nothing happens. But when I press second, I have the ability to go over. So I'm actually going to talk about I'm going to jump ahead and talk about second because I feel like I'm talking about it a lot, and it's important to the operations of the calculator. So all the buttons you see here, these are the first buttons. Okay, so if I press 7, it's going to give me a 7. If I press here, let me open a calculator. I'm going to add a new page. It's just going to be a simple calculator so we can see what happens here. If I wanted to do the square root of 2, you can see the square root right here above there's the exponent, the squared, but then there's also the square root. In order to, if I press 2 and then the squared button, it's going to give me 2 squared, but that's not what I want. I want the square root of 2. So in order to trigger this function right here, I'm going to hit what's called the second button. So you can see up here that the second button has been enabled. So every time I click it, you get a little piece of information saying, hey, the next button you click is going to be whatever the blue is. Whatever the blue above the button means that there's a second feature to that button. So I want the square root. So I pressed second right here. You can see that I have it triggered up here, and I'm going to then press it. Then you can see that the second feature disappeared. So I'll do that one more time. So watch up here when I do this. Second is enabled, square root, and now the second is unenabled. So I can put 2 in here, and then I can enter and get the result. Same thing for a lot of these features. These are all like the mathematical features. So when you're working with the calculator and things like that, you can access those. Like these are the parentheses, but if you press second, you can get brackets. So if I did 2 plus parentheses, and then I could do 2 times 6 and hit enter. Or I could press second and I could create some form of a set. Is the comma's down here. So 6 and 3 and 0, that would be inside my set. That's not something to do at the moment, not really important. But the other thing is, so these are the mathematical features, but if you want the actual operational features, save is a second feature, adding a new page. So if I wanted to add a fourth document to this, so right now I'm on the third, but if I wanted to add a fourth document, I'd press second and then page, and I'd be brought to the options for adding a new file to my document. So the menu, so let's go back. It will take me back to home, but if I press, where was I? I need to go back to where I was. Hold on. Yes, if I'm stuck in here and I go Control Document, I can hit Escape and get back to my different documents. So notice that I tried to go over. You had to press second every time to get to your different documents. And also to see all of your documents, you can press the second button, and then you can press this button right here, and it's kind of showing you that you're going to see all of your pages, and then I can quickly move along. I know that in some of the projects, the students are creating multiple pages. So if there's more than 4 pages, as we have here, we have 6, it's quicker to press second and go here and then traverse it through this menu as opposed to, here, let's go into here, as opposed to pressing second and cycling through by pressing the side, right and left D-pad buttons. Each document that you have, so let's go to the Python one, that's the most important for this program. You have the menu button. So every document you have has the different menu options. So you don't need to press second because you can see that menu is written directly on the button. So all you need to do is press menu, and then you'll get the menu options for that file type. In terms of the Python, this is the Python editor menu, and you have access to different actions, which is more like text formatting and opening files and things. The run feature is one of the ways to run, which we'll see in just a moment. And you have all these different options for working with the different modules and things. And if I go to, say, this calculator page and I press menu, you'll see that I have the ability to get all of these different mathematical operations, which again can also be, most of them can be done here, but as you can see by viewing this menu, there are a lot more options than buttons available. So that's why this menu exists. So if you can't find it here, you can find it in here. Really, there's nothing that you can't find inside of here. You can even add a little bit of programming into a calculator document, but that's not with Python, so we won't touch on that. There's multiple sections. So we got page, right? We have menu, and we've touched on page. So if you want to create a new page, you do second page. If you want to see the menu options for that document type, if you want to see the menu document, I'm on a blank. I need to go to something with value. Menu, like I just showed you, menu pulls up. This third one right here, if you press it, is a more in-depth menu for specific selections. So let's go into the actual Python programming. Back in the home, if you want to create a new Python program, you would press 1 and then A, it's the final option, so A, and then 1 again. So a new document of type Python, that's a new blank document. And for each document or each new Python file you create, you have to give it a name. So this time we'll call it test2. I know that we just created a pointless program a moment ago, but you give it a name and then you choose the type. The default is the blank program. This is just going to give you a blank program with no information added, and that's totally fine for when we're creating simple programs. So we're going to go with that for the moment, just as we demonstrate the basic usage of this Python editor. Now we have the basic program. If I do a hello world, again, like I said, the typing on here is a little interesting, so I'll do print. Let me see. Oh, I need the delete button is above here. This is kind of not frustrating, but you need to remember because the enter button's here, but the delete button is all the way up here. So that's one thing to be aware of. If I want to do quotations, I can do this button right here, this exclamation and question mark button, and it's going to bring me it's going to pull up different little symbols. So when you're doing your syntax and things, you've got quotations for here. So now I'll type my string. I'll just say hello. The space button is right here, and world. Hello world, and again I will press this button to get my closing quotations and then close that parenthesis. So now we have a basic, not hell world, we should add an O to that. So we have our basic hello world program, and there's a few ways to run a program. The first way would be through the editor. So you're going to press menu, and the second option in the menu, in the drop-down menu, is the run and 1. So we can go menu, 2 for run, and then 1 for run again. And we run it, and you see we get the shell output. It's saying that it's running test2.py, and then it gives us the output. And this is a shell, so we're not in our program. If I try to go back to my program, I again have to do control and then page, and it will bring me back here. So that was one way to run it, is by going to the menu, going to run, and then choosing run. But also up here in the menu, you can see that control plus R also runs. So I will have to see if it's capital. So we'll do control and then R, and that runs it as well. So that's a second way to run your programs, by pressing control and then R. All this stuff just takes time and practice, and you as the instructor finding your best way to execute programs and things. My favorite way, for some reason, just because my hands are usually up here, and usually you're running it like this, I press control menu and then 6 is run. That's the easiest way for me. I know that control R is only 2 buttons, but control menu 6 is the quickest way for me. So control menu 6, and that will run. So let's take a look at the menu real quick. Notice that if I'm in the shell and I hit menu, the menu pops up, because you can actually do coding in here. I can do 5 is greater than. I don't want to waste too much time on this. Nope. Yeah. Anyways, you can add the logic in there. Oh, it's in second here. So you do second, and then you press the equal sign, and it shows all the different logical operators. So say 5 is less than 10, and I can hit enter, and it will say true, because this is also a shell. It's the output shell, but you can also use it as if it was just a regular Python shell. It kind of doubles. When you're in here, let's take a look at the different modules. So you press menu and you'll want to come down here, and once you pass the first three options, action, run, and edit. Edit is a lot of quick editing. If you learn these, you will get really quick at programming with the calculator in the handheld. Most of the programming in this course is done within the student software, so I haven't necessarily used all of these to a large extent, but you can see jump to bottom, end of line, beginning of line, a lot of kind of cursor movements. But for on is programming Python programming specific commands. So for is built in. So if you want to create a function, if you want to make some control statements, some digital logic with a for loop or a while loop or an else statement, ops is going to have different comparison operators. List, these are all functions within a list. So if you have a list, this is creating a new list. If I actually press this, it will just give me the brackets. So, do what you will. But back in the built-ins, list operations, you've got list cast type, you've got the length of list, you have all these different options, append, split. All your basic list operations are within here, so you can either type them out or go into the menu and actually do them themselves. So let's actually do a quick little coding. I'll say list one equals, sorry, you probably can't see, don't want enter, I just want space. List equals, and then sorry, I'm looking at a screen. I'm looking through my camera screen doing this. And then I want to add a few values, 1, 2, 3, 1, 2, 3. Okay, so we have 1, 2, and 3, and we're going to go ahead and we're just going to print out that list. So as you can see, the typing is very slow, but I can go through here, I can go to built-ins, I can go to IO, and I can go print, and then I can type list 1. So we're going to print list 1. I'm going to enter again, and now I want to add a value to my list. So I'm going to go to menu, I'm going to go to for built-ins, for list, and then 6 append. And I'm going to add the value 2 to the end of my list. Now I need to add list here. So list 1. And then again, I want to print out this. So I'm going to go menu, 4, 6 IO, 1 print, and then I'll do list. Now, something that you could do to actually speed this up, as you've seen, I've written the word, the variable name list1 multiple times. I can click on here. I can set the cursor right here. Okay, and then I can actually copy it. I can do Control C, just like on a computer. Control C. Now if I go down here, let's do this same operation again. I'm going to, I want to append another value to my list. I can Control V, and you can see it added list 1. Obviously, I didn't want this, but Control C and Control V will copy and paste. So I'm going to add another value to my list, 4 to list operations, and then 6 to append. And this time we're going to append the value 99. And one last time, I'm going to go to 4 built-ins, 6, and 1 to print. And actually, I'm going to delete that parenthesis because I know that if I Control V, I'm going to get that again. I'm going to get my parenthesis list 1 naming. Now I'm going to go ahead and run it. So I'm going to do, let's do Control R this time. Control R. So you can see that we have a list. We added one value and we printed it out, and then we added another value and we printed it out. So I find that when coding on the actual handheld, which will happen within the first class, and then when the students are testing their code, whether it's on just the handheld or with the hub or with the rover unit, the best way to code fast and do simple modifications is by working with that menu feature, because rather than having to type all, append would be, you'd have to find the period and then type in, you do period, append, you'd have to find all the buttons, make the parentheses, add the values, or you could just go to the menu and code it that way. One last thing that I wanted to show before I end this little demo, actually two things I wanted to show. First, I'm going to show the templates a little bit further. So I'm going to add another Python document, and I'm going to call it test 3. So test 3, this time I'm not going to make a blank program. I'm going to select this, and I'm going to come down here, and you can see that I have all the different options for templates, project templates. And what this is going to do, this is going to give me the ability to import automatically all the modules needed to work with that kind of a tool. So if I was plotting something on a graph, this is going to import all the system and the PLT modules. Let's do a hub project. So if I press hub project, so test 3 is going to be a hub project. I'm going to select OK. You can see that it imported from TI Hub, import all, math all, time, import sleep. That's very important for the hub module, plot, and system. Now, let's go ahead and add a couple lines of code. So I'm going to make my hub make a sound. We're going to make it make a sound. Let's go menu. I've got the TI Hub module at 8, so I go 8. And you've got, we don't need the import because we already have that. That's part of the template. But the hub built-in devices, which is 2. And then from here, I've got 4 other options. So you can see that this module is actually pretty big. Each option has many different options within it. There's the color output, light output. I want the sound output. So I'm going to do the sound output. And I'm going to do note time. So I will do note time. And you can see that it gives me an autocomplete. When I add these specific method calls from the modules, the parameters are already set. So if I select that, it says example A4. So that's going to be an A note in the 4th octave. We cover that in another activity, but I'm going to go ahead and play an A. Oh, no, not all. Sorry. I needed to press caps. So shift, if you want a capital letter, you press, I didn't mean to press control. To get a capital letter, you want shift. So the notes are in capital letters. I'm going to do A4, and I'm going to do, this is duration possibility is 0.1 to 100 seconds. So I'm going to play A4 for 2 seconds, and then I'm going to do the same thing again. I'm going to go to menu, I'm going to go to 8 for hub, and then 2 for built-in devices, 3 for sound, and 2 for note. And this time I'm going to do an A in the 5th octave, and I'll play that for 2 seconds. So this is the entire program at the moment. All it's going to do is make 2 noises. So give me just a second. I'm going to grab the hub unit, which is right here. We're going to do a little demo on this in another video in just a moment. But this is your hub. And the way we're going to connect it is through this data port. Oh, excuse me. And the USB port right here. So you plug the 2 USB ports in. Right here, notice that this cable for plugging the hub to the handheld are different. You can see that the data port on the hub is the blockier USB. So I'm going to plug that in like this. And then I'm going to plug that in like that. And you can see that it automatically powers the hub on. And And so I will try to lift this up so you don't see my fingerprints. I'm going to run this program, and I'm going to do Control Menu 6. Actually, so this is a good example. And this is something we teach about in the classes, and I didn't think about. The computer is running so fast, it runs Command 1 and then Command 2, and so it all we hear is A5. It did play A4, but the A5 command overrode it on the output device. So what we're going to do is I'm going to add a new line. I'm going to go to Menu, and I want the time, which is going to be in more modules, A, and it is the second option, and I want sleep in seconds. And so for the amount of time that you want the note to play, you also want the program to sleep for that amount of time as well. So still connected, still powered on, I can just simply run the program again. I'm not sure if you could hear that, so I'm going to put it up by my microphone, my headphones. Oh, I'm in the shell command, and I tried to run it. That happens all the time. You want to make sure that you move back over to your program, Control Menu 6. And you can see that we get an output that basically means no errors occurred. Just for reference, the sound is on the bottom. It's clearly labeled. Everything on this TI hub is clearly labeled. If you just take the moment to look into it, it's pretty interesting. But we'll cover that in the next section. So that is the product demo for the TI Nspire CX2. I hope that this portion of the video was helpful and got you a little more comfortable with working with this handheld. Again, as I've said multiple times, there's so much to this handheld. It's really going to take you taking some time to understand the video or understand the hardware and really dive into the different features and capabilities of this hardware. So for this section of the demo, we're going to take a look at the TI Nspire student software. This is the software that both the teacher, the instructor, and the students will be using to program their Python 3 and various TNS files within the course. The first section is the download. So let's go over to the downloads now and see what that looks like. Following that first link that was provided in the slides, you will be brought to this page. Depending on the computer that your location will be using, whether it is the iMac, iSports computer, laptop, or other, the students will have, or you should have these softwares downloaded on the computers before the class is executed. The students will be shown these pages throughout the courses just for supplemental information if they were to take this further into their home and want to practice more on their own, but this is the page for downloading the software for your location. What you're going to do is these top 3 items right here, these are the softwares that you're going to choose. I'm on a Mac computer, so I would choose this first one for Macintosh. If you're on a Windows, you can choose this Windows software right here. Following the second link provided in the slideshow will take you to the Software Service Center. Now, your location will need to create a user account in order to access the license that are provided in order to use the student software. The link again takes you to this page, and I already have an account, so I'm going to log into the account, and you will see a product list page right here. This is where you can redeem your license. So you will get a software license via us or TI within the coming days. And you really just need this page right here, the product list. You can put the redemption code in and redeem it, as well as you can go to this page right here, which is essentially the same page. You're going to get a code and you'll put it in here. Now, I'm not entirely sure on how TI is going to dole out the softwares at this moment, but when I received my software, it was a single link with the number of software licenses included. So I simply put the claim number in, and it said I have multiple software licenses. So if we go to the redemption history, this is my redemption code here, and you can see that TI gave me 3 license activations, and I currently have 2 unallocated. I've only used the one for myself for writing the curriculum, but this is what the software looks like. So when you're getting ready to sign the licenses for the different student softwares, this is where you will go and redeem your license code. Now that you know how to download and set up your student software, let's go ahead and jump into the student software and see the following items. We will take a look at the handheld emulation tab, as well as how to create a new document, similar structure as the handheld demo. We will learn about saving documents to the computer and to the handheld because they are 2 different processes. We'll take a look at the different editors as we did with the handheld. We'll also take a look at some fun little things like animating graphing. We will also take a look at the Python programming, which you will see how to change window sizes for better coding environments. You will again do error reading, and we'll also take a look at the auto completion provided with the software. If this is your first time opening the student software, this is not the screen you will see. Going through the download and license redemption process will take you through the download and installation process, but also once you open the application for the first time, you'll be put through a user interface asking you to verify users and license numbers because a license is required to work with this application. So the first thing that we want to look at is the hardware emulation. Now, when you open the software, you will get this blank project tab, which you will see is emulating the handheld. This screen is an emulation of the handheld screen. Everything you will see here is possible on the handheld as well as the software. You have a control menu right here, this little navigator menu. The third option is the handheld emulation. So anything you do on the handheld or you want to use the buttons, you can do for the software. So if I press the home button, it's going to take me to the home, just like we saw with the handheld. There are many different options. It's all the same as what we saw with the handheld demo, so I won't go too in depth with that, but just know at any point you can click on here and use the same button configuration. Like if I want to make a new document on the handheld using buttons, I can press 1 from the home menu and it will bring me to a new document window. Same thing is you can also use the mouse. So if I wanted to browse files, I could browse files. I can go back home. So let's create a new document real quick just to demonstrate that. So we're going to add a simple calculator function, and I can do a multitude of things. I can use the buttons with the mouse, do 5 plus 5, and it will work just as intended. I can also click on the screen and type directly onto the screen and do 5 plus 5, and I just press enter with the keyboard of my computer and get the same output. So everything you can do on the handheld can be completed through the software emulation. The student software just adds added computer functionality as well as, in my opinion, an ease of use. So that was actually covering both the handheld emulation and the new document. So let's go ahead and talk about saving to the computer. So I'm going to create a multi-page document. We've got a calculator. I'm going to add a note. So I'm going to say this is my notes, and I'm going to also add a spreadsheet with some different values. Okay, so we've got a multi-page document which you can traverse through this second tab, which is the Documents toolbox, and we can view the different pages, the different problems added, the different pages added to this problem. Sorry, I've got all my words mixed up. If I want to save this project, I can click the Save button, and it will bring up my computer Finder window. And actually, with the creation of the TI student software with the download and installation, a new folder will be created, usually in your documents directory, where you can then save all of your projects into one space. So when I save it, I want to give it something, a unique title. I will say my student demo, and I hit save, and now it is saved. So now I can actually close this window out. I can create a new document if I want, or I can work on the existing document. So if I have an existing document that I want to open up, I can press the open button, and I can go find my student demo.tns. It saves as a TNS file, and it will bring all my pages in this document back up. Let's take a quick look at the different editor menus that you have when working with files. We covered this with the demo of the handheld in depth, so I will not be covering all the different functionalities in this video because you can go back and rewatch them there. But as you saw in the demo with the different files, I've got a calculator, a notes, and a spreadsheet. If I go to the first tab in the document toolbox, you will see the editor window. And each file, each different page instance has a different menu. So in the calculator, of course, I have all the different functions and things that I can introduce to the calculator. Anything you want, anything you can really think of is here. You just have to find the right tab for it. If I go to my notes, the editor menu is going to look different. So a lot of it is with text formatting and things like that. Again, with the spreadsheet, if I go to the editor menu, I can select rows. Oh, let's see if I can select the whole column, and I can do different things with the selected column. So it really just takes some practice and interest in diving into the menus to see the complete functionality. These menus are where the functionality of these files really are exemplified. So it really just takes you kind of diving into them as well as diving into the student user guides. Let's go ahead and add an additional page of a graph. So this is similar to the calculator function as we saw in the demo. It's a place where you can just write simple functions down and see how they graph out. And I just wanted to show a couple pieces of the functionality. So we could do x squared So when I create this function for the graph, I added a couple variables. I said x squared, which is inputted into the function, x squared plus x times c plus b. And when I write these letters down, the calculator or in the software is going to automatically assume that I want to create variables for those. So it's going to ask me if I want to create sliders. This is a really cool function, basic function for the student software. So I'm going to hit OK. So it's going to say create a slider for C and B, and it's going to give me basic min max range as well as a default range. And then it's going to actually graph out the function for me. So this is the graph right here. I can grab it with my mouse. I can click and grab it, maybe put it down here somewhere. And then a really cool thing is I can grab the slider and I can change the C value and see the translation there. And I can also grab the B value and see the translation there, right? That's pretty interesting. And another part of this is if I right click on here, there's additional settings for the sliders themselves. I can do this. I really like this animate function because it allows the students to kind of in real time see, oh, when the B value changes, it will do something. And additionally, I can animate multiple sliders at one time if I can select it correctly. So this kind of defeats the purpose at a certain range because there's so many things going on, it's hard to understand, but it's interesting to see that we can write these functions and we can determine what they look like on a graph. The last section of this student software demo that we're going to take a look at is looking at the Python programming environment. So as with the other pages, you would go up to the insert and you would choose new Python. Actually, let's go to a new document. So I'm going to go from the home screen to new document, and it's going to ask me if I want to save these. I'm going to say no. And it's going to give me all the options. And the final option is the Python uh, programs. So I will choose A1 for new, and I will give it a name. I'll say my Py demo, and I'm going to choose a blank program. Actually, I'm going to choose a random simulation, but I just wanted to show you can scroll through all these different modules, and it will include the necessary packages for working with Python. So I'll hit OK. And you'll see that I get from math import all and from random import all. One thing that I wanted to demonstrate on the student software when coding in Python is the different views. So up in the right corner, you have document preview, and you have handheld versus computer. Excuse me. The handheld is going to show the same kind of output that you would see on the handheld screen. But for the computer, you get a much larger screen to work with. So this is definitely the way to go with the student software, is to get the bigger screen, and you can see more lines of code as opposed to the handheld. Now note that sometimes working with different modules, such as the graphing or the rover or the hub unit modules, when you work with those, the only way that you can execute them is when you're in handheld preview mode. So if you're in computer mode and you try to run it by right clicking and go to run, then it will give you an error saying that you have to be in the handheld preview mode. So just with all things, let's see, random, oh, I think it's rand int. Let's just give a random integer. So 1 through 5, and I'll print out x, just simple stuff here. And I've got some code, and I can execute this code in a multitude of ways. I can do as you would with the actual handheld. You can go second, menu, oh, and it doesn't pop up. That's okay. I believe it pops up in this tab here. You can go to the Python editor, and you can do run, and that will run your code. And you can see this takes me to the shell. So it gives me a new shell to work with. So I actually have to toggle back and forth between those. If you're in the computer viewing mode, you have to go to this screen to toggle back and forth. If you're in the handheld mode, you can simply click between the tabs. So on the computer mode, I can also, in the coding environment, right click and choose run by clicking, and you'll see I get another ran instance. If I go back, something that you might not have noticed is when I did this ran int, it did not autocomplete. So rand int, which is a method for getting a random integer between two values, say 1, comma, 1000, and when I run it, it runs. But the important thing to notice is that the autocomplete doesn't happen when you're actually just typing the code. In order to get autocomplete functionality, you have to go to the editor. I would have to find the module I want, which is random, and I'd go and find rand int, and then I have the autocomplete. So when I type, I can hit tab, and it will bring me to the different parameters within the method call. And again, I can run this, and it gives me a random number. So in terms of error handling, the student software doesn't give a whole lot of information on where the error exists. So if I do this, let's say I remove this comma, and I forget the comma, and I run, I'm simply going to get syntax error, invalid syntax. If I go to the run code, it's not going to tell me what I did wrong. But I know that I have this comma. So it's really important that you as the instructor help the students identify their small bugs in their code. That is a big ask for you as the instructor, is to, when your student has an issue, being able to scan that code quickly and look for the small syntax errors, that's going to be the biggest issue with students learning Python in such a quick fashion, is the ability when they write syntax errors, whether they're missing a semicolon or other things like that. So we could actually kind of extend this. I'm going to do this and see if I can get a different error message. I'm going to say for I in range 10, and then print 500. I'm not sure if I will get an error if I remove this semicolon. So I remove the semicolon for the for loop to see if it gives me an error on a specific line. So it did not. Let's see if I remove this. Sometimes it will run and sometimes it won't. So in certain situations, when you get an error, you will get a simple error message in the shell output, and it will say, all the different callbacks as you would see in a normal Python editor. There's no error string that you usually receive with the Python editor, but it will tell you what line the error is occurring on. So if you're looking for which line, right here is the line number. So right now I'm on line 1, and as I go down the Python program, you can see line 8, 9, 10, all the way to the bottom of the program. So that's really the extent to the errors that the software will give you. It will either flat out tell you that you have a syntax error somewhere, and in that case, you need to look for a semicolon or a parenthesis out of place or an indentation error, something like that. But sometimes if a method is not being used in the correct way and the code does run and execute, you'll get an error, a short error message down in the Python shell. A quick note about executing the course when using the student software. The course will give you all the information you need in order to complete the course. In order to complete the different activities, especially with the time constraints that we're working with, you as the instructor can extend the course by diving into the student software. The possibilities are quite endless with the student software. The functionality on each page, the ability to interact with pages and create dynamic notes and highlighting and bolding and using different functions in the calculator, or there's many different sorting algorithms within the spreadsheet, and you can do spreadsheet notation and things like that. All those are at your disposal, but for the execution of the course will tell you everything you need. But to execute the course in a higher level, it is on you to go and dive into the student software and really extend it for the students. So you can seem competent and have the ability to give the students a really high class training on the student software. And this goes for not only the student software, but the handheld and the rover and the hub units. All the different resources that we have are so vast that there's no way we can implement all of them into the curriculum nor into this training video, because this video would be hours long. So please take the time to explore the software and get used to the different functionalities and identify your workflow. As I've mentioned, there's multiple ways to do things, whether it's creating documents, writing Python code, modifying your document. There's many ways to do all of these different actions. And so when you find your workflow that works best for you, that's the best way to teach the kids, is really understand the way that you like to do things and give the kids some valuable insight on how to work with these products. This is the TI Innovator Hub. It is a really sleek, nice, high quality microcontroller. Um, I am a huge fan of this. It's a blast to work with. It extends very, very far, um, pretty far past the scope of this class, that's for sure. The students are going to be using it for just a few features, really getting kind of the basics and understanding of how it works. In the full bootcamp course, they will dive further into it, but for the spring break camp, they will just be learning kind of the basic functionality of how it works. So the first thing is connecting to TI, and we just saw that in the product demo for the handheld. Um, And what it is you have a data port right here, and you have a USB port right here. I don't know if you can, hopefully you can see that. Camera's a little far. Right there. So you would take the correct USB plug, you plug it in like that, and take this. Again, I'm looking at two screens at the same time. So when you plug it in, the handheld will power the microcontroller. You can power it via just a different USB. You can actually plug it into a USB and actually upload code to it, but we won't be doing that. As well as you can also be, you'll plug it into the rover when you use it as a bridge. For the scope of the course, the students are really going to be using it for, like I mentioned, the different simple sensors and output features of the hub unit, which is the sound, the lights, the light sensor, those kind of pre-built modules that they can code with Python. Additionally, the hub will be used as a bridge, as I just mentioned. We'll see in the next product video, the little demo video, that this array of outputs connects directly to a ribbon that connects to the TI Innovator rover and allows it to control the motors and all the different features of the rover. So that's the scope of how they're going to be using this. I know that the slide says that we're going to be doing a music demo, but we just did a music demo. So for this, I want to show the LED light. So I'm going to actually add an additional Python program. I'm going to do control page, and it's going to give me my options. I'm going to do Python, new, and I'm going to say hub demo. If I can find the buttons. Hub demo, so hub demo, here we go. And the template I'm going to choose again is the hub project. So I chose hub project, and I go okay, and it gives me all the different modules that I will need or want to use with the TI hub. So this is a simple project that the students will work on. We can do a for loop. Let's try to add a for loop using the menu programming. So I go to control, and I will do a simple for index in range size. We'll just call that I, for I in range. We'll say 10, and I'll hit enter. And so this is something we haven't touched on yet, but when you make a for loop or a control block, it will auto indent, which is very nice, and it actually shows the dots for the indentation, which is good for the students when they're learning about programming, and indentation can sometimes be a hassle to deal with. So we're going to simply make this block or the LED change colors. And actually we're going to go a little bit further. I'm going to delete this, and we're going to say 255 times. And so I want to make 3 variables. I'm going to do R. Oh, I press enter again. I need to press space. R equals, and I want this to be a random value. So I'll go 6. Let's see, is the random module added? No, the random module is not added to this program. So I'm going to come back up here because this is where all of your import statements should be. And I will go to 6 random and then press 1 to from random import all. So you can see that added the entire random module. So R is going to equal random integer. So we go 6 and 4, and we'll give it a value from 0 to 255. And now I want to copy this whole line. So this is a little finicky. Come on, sorry. Sometimes when you try to do it, it doesn't want to do it, but that's just because I'm, okay, we'll go ahead and write a whole nother one. So red, green equals random randint from 0 to 255. And then once more, I'll do blue for red, green, blue equals 6, 4, 0. See how it was kind of hard to work with this stuff, but see how fast I did that by using the menu feature? That's really nice. That a kind of demonstration of, oh, well, it's too hard to do here, so just go through the menu. The menu is definitely the fastest thing to do. So we'll go to the TI Hub module, which is an 8, and I'll go back to 2, which is the output. Number 1 is color output, and I want RGB red, green, blue. So I press 1, and then what am I going to do? I'm going to input my variables just like you would in any other Python program. I'm going to put the green variable in there, and then I'm going to put the blue variable in there as well. So 3 variables, RGB, they're all going to have random values. And then what I want to do, as we saw with the music demo, I need to add a sleep call, because the sleep call is, if I don't have sleep in there, it will cycle so fast that we'll never see any of the different colors. So we'll add this and we'll have it sleep for 0.2 seconds. So we're already connected. We've got our coding completed, and we're just going to go ahead and run and see if we did it correctly. Block is not defined. So let's take a look. Where is the word block used? Let's check down here. Is any, oh, yeah. So this was the auto-generated code that it gave me, and it actually reads it as text. So that's pretty interesting. I actually didn't know that. Control menu 6 to run. And we can see that it works fine. And we get this little clock wheel for when a program is running. If we do try to input anything, we can use the get key method, which is within the TI system library. And we can still input values during this period, but we don't have that a part of our code at the moment. So you can see that this is running just fine. We're getting a different color each iteration. It's pretty nice bright light. See how close we can get that. But yes, that is the TI Innovator Hub. I hope that this little product demo is making you feel a lot more comfortable with working with it. As you'll see later on, working with the student software is much quicker because you can do everything through the keyboard, but things are still very possible with the handheld, coding with the handheld on one of these devices. So something that I recommend is have them build their initial code on the student software, but then when they disconnect from the student software, they can iterate upon here and rerun their code. So they don't have to unplug and then plug into the student software and then upload the code. They can upload it once and then make rapid changes within the hardware to the actual program itself. The final piece of hardware that we're going to take a look at and play with a little bit is the TI Innovator Rover. My camera angle is not too wide, so I'm going to have to rotate it a little bit. You can see you have an ultrasonic sensor for gathering light. You got a pen holder where you can put a Sharpie into it and actually draw on a piece of paper. It's a very, very cool little feature. This is a nice aluminum case. It's very strong. It's a very durable device. And what's really cool, what I really like, and you should take advantage of as an instructor, is the fact that the whole system is open. So we can see every single part of this system, all the connections, all the wires, and with a little bit of digging, just by putting the rover up to your face here, let me turn it this way, we can see what everything is. We can see where all the connections are and how they work. It's very easy to see. So if we look up here, we can see that this purple square is the RGB sensor. This is the color sensor. So you've got a little LED diode along with the color sensor right there, and a nice little connector pin that travels down and into here. And if we look at it closely, there is also, you can't see it, and I won't be able to show it in this video, but if you look right in there, it actually says color sensor. So all these different things are labeled. So right there, you can see left motor. So these two pins, this is a power and a neutral, and those two pins travel to this motor, which is really cool. I believe that there's probably a bridge sensor in here, or a bridge chip in here, that will allow the motor to rotate forward and backwards, not just in a single direction. But it is a really cool piece of hardware. I'm a huge fan of it. I just went ahead and took everything out because I want to demonstrate getting it working. So this is the hub, or this is the hub that was in there, but this is the rover. There's nothing in here. This is just a case for the hub itself. You have this. This is a I2C wire for different data communication. So I'm going to quickly demonstrate putting it together, and the way that I found is the best. So you have this little pin ribbon kind of wiring right here. This connector plugs into this base, and these little arms will grab it. But I found that the best way to do this is by connecting it to the hub unit first. One thing to notice is you got your two power ports right here, a 3 and a 5 volt, and those are identified with a red wire. So you want to take these, plug it in like that, go ahead and press it nice and firm so that it's in there. And then it goes, this is the bottom and this is the bottom of the hub, so they both align. What I like to do is connect this ribbon first and then bring the hub in. They've got two little slats on the side so you can actually get your fingers in there. It's for the data ports, but you can also slide your fingers in there. So I like to connect this first, then bring it in. You see this little clip right here. Let's try that again so you can really see it. Pay attention to right here. This will let you know that it's locked in. You can see that right there, that little clip. You just pull that down. That's what secures the hub in there. I bring this under, move this I2C wire out of the way, and then you just guide the connector into place. Make sure that these little tabs are open, and you guide these in place. You should hear them both click. So that second one was a little tough, but there you go. You see that they're in there and they're connected and they are not going anywhere. So that's good. Make sure that it's somewhat pressed down. It does fold. I have this I2C wire connected like this, so it just runs under the bottom here. And so our hub unit is now attached and docked inside the rover. And the next thing we need to do is attach the CX2 onto this. And how do we do that? Well, first we want to remove this cover, and then we're going to slide it in. But you'll notice you have these 4 black tabs, and they are marked for the CX and the CE. We have a CX, so you want to turn all of them like this. And you'll see that there's these little grooves that dock into these little pinholes. So once your handheld is removed and those slats are turned 90 degrees, you can just slide your handheld all the way up till it hits this little bumper, and then you turn the CX tab towards the handheld. So the CE is the TI-84 CE. That's a different handheld that we will not be using in this course. So make sure that you've got it on the CX pins. Now, the same wire that was used to connect the hub will still connect the handheld to the hub. So I'm going to go ahead and make sure that I've
connect these. It's gonna be a little hard to see that on the camera, but that's okay. And then I just wrap this around, and did I do it wrong? I did do it wrong. I put the wrong ones in. It fits, one fits both and one only fits the other. Sorry, this is probably not the best thing to watch on this camera angle. And then just plug this I2C wire in. It actually is really not necessary if you don't want it, but it's good to just have it there and plugged in and out of the way. So now our handheld will have the program, and it will send the program to the hub unit, and then the hub unit will know how to send the data to the different motors, grab the data from the sensors. That's really all that's happening here, right? These pin connections are pre-programmed to the hub and to our Python program that say, this wire right here connects to this wire right here. So when we want the data from the RGB sensor, pull the information from wires 1, 2, 3, 4, and 5, etc. So there's that. I'm going to also show you how to turn it on. This unit has its own battery, so make sure to keep it charged. Let's see where the charging port is. I believe it's on this side. Yeah, it's right here. So you can use a regular USB to plug into here and charge the rover that is used for turning the motors and things. So that's what's really cool about a microcontroller. We have the microcontroller to instruct the program and instruct the sensors, but the microcontroller also controls, hey, use this power from this power source. So the power source is coming from the rover, but the information is coming from the hub. So that's a really interesting feature of microcontrollers. So I've pulled up the student software here, and we're going to go ahead and create a Python program, and I'm going to call it rover drive. And as our camera shows, we don't have a whole lot of space, so I'm just going to make it drive forward and back, but I will choose the rover coding template, choose OK, and you can see that it gives us all the necessary modules. And I'm going to go to computer view so we have a little bit more room. Hopefully, actually, I'm going to go back to handheld viewed because so you guys can see it clearer. And all I'm going to do, the rover has been imported as RV. So anytime you're calling one of the rover commands, it's going to be rv.forward, rv.left, rv.color sensor, rv.ultrasonic sensor. We're going to use this RV nomenclature to do this. So let's do drive forward and back 5 times. And we're going to do 4. I'm going to give us some space here so we can see a little bit. And then here, I still, even in the student software, I like to go through the menu just to, when I'm using the different modules, because it's a little bit quicker. So you can see rv.forward and then grid units. The grid units are something that you're going to have to work with and test out for yourself so that you can kind of see how far things are. I'm just going to say 3 grid units forward, and then I'm going to do drive, and we're going to go backwards, and we're going to do 3 grid units backwards. So the rover should go forward, come backwards, go forward. Very simple, but that's how this program will work. There's a whole host of things in here. Outputs for the color RGB, you can make it change its color. You can make the color blink. You can change you can drive using just the left motor. You can say, okay, turn the left motor 90 enough to turn 90 degrees, and it will do that. And you can also control both motors, but the driving feature is definitely the most efficient thing to do. So what I'm going to do now, hopefully you can see this screen, I'm actually going to unplug my handheld, from the hub, and I'm going to plug it into my computer. So currently it is plugged into my computer, and I'm going to save to handheld. This is file save to handheld. And it's probably going to ask me to save the document. We're going to save it as Rover Demo 1. And it shows the connected hardware. So I have one TI Inspire CX2 connected. Takes a second, and I'm just going to save it in the top directory. And you'll see on my screen, once the project has transferred, it's going to say, hey, there's this new document received. Do you want to open it, go to it, or just ignore it? I want to open it. I don't want to save the current document that I have because it doesn't really matter. So you can see that now we have the same document. I'm going to remove the student software. So I will now unplug from the computer and plug back into the hub unit. So that was the line that went into the hub unit. And now we need to turn the rover on. So you have this power button right here on the front right side. And you can see I've got full power on the rover. I'm going to back it up just a touch because I'm not really sure how far the 3 units is going to be. But I will do Control Menu 6 to run. And there we go. So simple programming logic, 4i in range 5, drive forward, drive backwards. There is a whole host of things that we can do, excuse me, and things that the students will do throughout the program. Of course, things like, gather the distance from the wall and drive up to the wall until it's, 5 centimeters away or whatever it is. So that is the product demo for the TI Innovator Rover, and with all the hardware and things attached to it. So I hope that this gives you a better feel for how everything works and the workflow for connecting the hardware and the hub and the rover and getting all of it to work. Yeah. And with that, we have concluded the iCode plus Texas Instruments Bootcamp Spring Break Pilot Program Training. Um, I know this video is a lot. I know that there's a lot of information to take in, especially for a 3-day camp. So I hope that this information finds you well. I hope that, if you're having trouble with the hub stuff, go to the hub stuff. If you're having trouble with the handheld stuff, go to the handheld. Use those resources. Use the outlines for the day structure that we've created for you. Dive into the material, dive into the actual courses and classes, know the activities and the programming challenges that the students are going to be asked to create, and be ready to extend them. It is your job as an instructor to take those projects that we've made, complete them, and then push the students a little bit further based on their skill set. We create these Python programs and the programs for the TI hardware that demonstrate skills and ability in computer science and programming, but it's up to you as the instructor to push those programs further that are customizable for your class and what your class is interested in. Thank you so much for your time. My name is Carter Ash. I'm the developer for the TI Bootcamp. Again, I really appreciate your time. If you have any questions regarding this material, there has been a Basecamp project set up. You can ask questions through there. I will respond. You can email me directly at carter.ash96. I highly recommend that you ask the questions on Basecamp so that all other locations executing this program get to see your feedback and think about things that maybe they hadn't thought about or gotten to yet. So please be vocal on Basecamp. I want to know your feedback. And with the note taking, as you're running these courses, please take notes, talk with your students, be conscious of how your students are responding to the material and the coursework. So thank you so much for your time, and we'll be in touch. Bye-bye.